All right, guys, we're gonna dissect. We're gonna look at a current position that one of the students has. Okay, the stock is currently 66.50. The August 60 calls are currently $10, and we paid $6.70. Okay, so right now the current P&L, unrealized, but current P&L theoretically would be what? And I'm sorry, what I didn't say is we have two of these. Okay, we paid $6.70 each, and we own two of them. So what is our current P&L? Gary, it's definitely not negative. Why would it be negative? We paid $6.70. They're worth $10 right now. Joe's got it right. So the current P&L would be a positive $330 times two contracts times the multiplier of 100, or current P&L of $660. Okay, everybody follow along so far? Because this is the easy stuff. Now we're going to get to why I'm bringing this up. Okay, how can we determine when we will have a profit of $1,000? How can we determine that? Yeah, Chris, that too, the Duralta. I like that. Yes. Christopher, Chris, yes. No, it's all good. Okay. Now, it could also be a volatility issue, right? It could also be an increase in Vega, and we'll address that in a moment. But typically we would just go to, well, the value of the option is going to change by the delta. Okay, so the delta of each option here is, let's just round this, guys. It's 72, but let's round it to 70. Okay. Okay, the delta of each call option equals plus 70. Okay, I know how to do this. I can put the math up on the screen. How do we back into figuring out at what stock price now we're going to realize a profit of $1,000? Okay, anybody else? Here's how I would do it. Okay, here's how I would do it. We need a total additional profit of $340 or $170 per option, right? To get from 660 to 1,000, Peter, you would definitely use gamma, but for this purpose, I'm not going to bring gamma into it. We're just going to focus on the delta, but you are 100% accurate. Okay, but to get to 1,000, we need $340 more, or 170 per option. Okay, how can we get $170 more per option? So Chris, your equation, your calculation is exactly correct if we had divided that by 2. Okay, so the equation would be we need $170. We have a 70 delta option. So 170 divided by 70 is a move in the stock of roughly $2.43. So this 243 is the move in the stock we need. Okay, so if we take current stock price of $66.50 plus that 243, that gets us right to about $68.93. So, Russell, there's your answer. Not going to be precise to the penny, but if the stock rallies to about that level, you are going to see an increase just from delta. Again, nothing else. Nothing else. Not gamma, not vega yet, but just from delta, this would get the values of these options up to where you need them to be to have a total value or a total profit of $1,000. Does that make sense to everybody, especially you, Russell, since you're the one that asked about it? Awesome. Now, I did throw in earlier the fact that we could make money on this or additional profit due to volatility. Okay, so do you guys want to now look at that? I'm going to throw this to you. Okay, let me go to page 2 of this. Okay, this is plant. Whoops. Plant discussion. Page 2. Okay, again, the stock was $66.50. And the value of each of our options are $10. Okay, so besides delta, yeah, but Antoine, we're just focusing on the current position that he has, okay? Besides delta, how else could the value of each of those options increase or, quite frankly, decrease, but how else exactly? So besides delta, the value of an option can plus or minus by its volatility risk or its vega. Okay, so what is the vega for each of these options that Russell owns? And I have it listed here. Right here, guys. Everybody see that? This is the Vega column. Okay. Line, yes, 1379. We're going to round that off just for example purposes right now. And we're going to say that the Vega risk of each of these options is 14 cents. Okay. That's what this 1379, that's actually 13.79 cents or 14 cents. Okay. Everybody see that? Okay. So the Vega of the August 60 call, and unlike delta, where call and put deltas are not the same unless they're both at the money and they're 50-50, Vega is the same whether it's a call or a put option. Okay, so Vega of the August 60, again, whether it's call or put, is going to be 1379. And that is measured in cents, okay? So we are going to round this to 14 or 14 cents, okay? Now, maybe the stock doesn't move, but for some reason volatility explodes in Planet, okay? So remember, our current P&L for two options is $660. We want to see an additional $340 in P&L to get to $1,000 profit. How can that happen using Vega? How can that happen from a volatility standpoint? What would have to happen? What's the math? Chris has it. Okay. We still need an additional $1.70 per option, right? We still need to see that increase. But now, instead of looking at it from a delta standpoint, if we use the same type of math, you got it, Sam, and say, okay, we need $1.70, and the Vega is 14. Okay. That equals 12.14. We need to see implied vol increase by 12.14. Okay, so right now the current implied volatility is 36.9. Everybody see that? Okay, so current implied vol is 36.9. If vol moves to 36.9 plus the 12.14, or basically 49.04, okay, and to prove this out, guys, watch this. Okay, watch what happens to the value of this option here that's showing 10 bucks. If I increase the implied vol here by roughly 12 points to 49. Okay. 1, 2, 3. Option increased in value by how much? Exactly. We were looking for $1.70 per option. No, Russell, not 1020. We're looking at the theoretical value, the midpoint here. Let's look at that again, Russell. Okay, right now it's 10 bucks. If I increase that implied vol to 49, 1168. Okay, Sam. Here you can see the theoretical value is 10 bucks, right? Just that's the midpoint of the current market. 10 bucks. The implied vol is 37. Okay, we said we need to increase the implied vol by about 12 points. So I'm going to just increase the implied vol to 49, and look what it did to the value of that option. Increased it now because it's, just a tick or two away by $1.70. Ah, there you go, Chris. Exactly. The new value of each option is 1170. I agree with that, Sam. We will walk through it in Thinkorswim. Okay, so the reason I just wanted to go through this discussion, this explanation here, I wanted to show you, how we, typically calculate the value of an option or the value of a position just using delta, which is the kind of the standard. But also, there are other Greeks or other properties of options that obviously affect the price of an option. Okay. So Russell, thank you. Thank you for bringing this up. Again, this is why I encourage everybody here to always ask questions, because when you guys ask questions, even if it's something, and I'm saying selfish not in a bad way, but even if it's something that is, just for a position that you have, when it leads to a discussion like what we just had, everybody gets to learn. All right? Gary, it's not going to change much. It is going to affect the value of the option, but delta-wise, not going to change by much. Sam, your question, I don't want to say it's irrelevant, but for this explanation here, this was just how do we calculate a change in option price. This is not Thinkorswim that I have up here. There is that on Thinkorswim. All right, let me wrap this up here, get the video and the whiteboard up here, and we will be moving on. Russell, thank you again.